So alright, this is tutorial for experiment M2 on simple harmonic motion. So these are the questions given. So the first thing, you set your pendulum and everything that you need. Then the next thing is for you to start solving. We've done the one of the angle of 15 degree and you've relaxed it. Then the next thing is to get your period. Remember, we got our T average from T1 and T2. So after everything we got in our graph, we got these things for our graph. Then our T1 and T2. Our T1 and T2, we got it. See our T1 and T2, we got it. We added it together, divided by 2 to get our T average. Then the next question here is this, that you should get your period, and it's T average over T of 20. So you get your T average over 20, you get it in seconds. Then you get your angular frequency, 2 pi over your period. 2 pi over your period. Then that's what you get here. 2 pi is 3.14 over your period. Then you get it. So everything you're getting now is based on what is in your table of values. So if you can see, my table of values is like this. If your table of values is not like this, you may not really get the same figures with me. So you are working based on the figures you have, not necessarily my figure. So now we are done with this first question. Then I says we should arrangement of everything. So now we are in this place. We are in VI, that is plotting a graph of. We are plotting a graph of ln n against n, not log 10. Not log n against n. So we plotted the graph of ln n against n. So now this is my graph. Again, I'm saying is based on this, my n, that's my s units, and this is my y, that's my ln n, a graph of ln n against n. So for my s axis is 2 centimeter to 5 units, that's 5, 10, 15, 20, 25, 30. Then my y axis is 2 cm to 0.1 units. Why I'm using 0.1 units is because I have 3.1, 3.2, 3.3, so that it will help in splitting. So now we're plotting a graph of this last one against this. So that's what we are going to use. So so what I want you to have in mind is that this thing is simple, and why we are using 0.1 units is 3.1. If you add 0.1 to it, it's going to give you 3.2. If you add 0.1 to 3.2, it's going to give you 3.3. And each of these boxes is 1 centimeter. So we are using 2 of it so that we have space. That's why it's 2 cm to 1 unit. So now remember, let's just take the first one, 0.0, and the last this one is 0.0, and then this is 3.9120. So see how I want you to do it. So this is your 0, right? And your y-axis is 3.9. Remember, it's 3.91. So you check your 3.91, you give a dot and then a circle. Then you go to the next one, 5.0, and then 3.7955. So this 5, you trace it, 3.7, you read it and circle yours. Then you come to 10. I've told you, if your table of value is not exactly as mine, you may not be getting the same figures, but just understand the fundamentals so that you'll be able to do it. Then 10, 3.624. So you come to you look for 10, you go up, 3.6 is here, right? 3.6 is here. Then I'm just going to put my own in 3.61, 3.2. So that's how you're going to do it till you get to this place. When you're done, just position. Remember what, if you want to get, this is not really a graph of best fit, because graph of best fit is meant to have all the points aligned in the line. But now the point is, even if all of them are not in the line, as you can see, 4 points joined against 2 points. So now another thing is, when you are joining, make sure that the ones that do not enter the line, one is at the upside, the other one is at the downside. And this is a negative graph because it's pointing backwards, you get. So when you draw your line, position your ruler very well and get your best points, and make sure that two, like the remaining two, should not be one side, they should be on the different side of the graphs. So when you are done joining, you then calculate this. Your line is going to help you calculate your slope. So for our slope now, that's the next question. Our next question is determine the slope. So to determine your slope is change in lane n over change in n. So change in lane n, you calculate it from here. Remember what you got, 3.7999 minus 3.2, this 3.21, 0.22, 0.23, 0.24, 0.25, 0.26. So that's where I got this, my 3.2600 from, over this 5 for your, this one, 5 minus 25. So that's why I got my slope for, and because it's a negative graph, that's why my slope is having negative. Then the next question is find the relaxation time, the coefficient of the damping B, and the quality factor. So if you check, if you come to this theory part, you see where you are given slope is equal to, find your relaxation time, slope is equal to negative period over relaxation time, coefficient of damping B is equal to 2m over relaxation time, quality factor is equal to Q over angular frequency over relaxation time. So all these things are here. So when you want to get your relaxation time, slope is equal to negative period over relaxation. So if you make your relaxation time the subject of the formula, then negative period over slope. Remember what you got in your slope. So this thing you got in your slope now is what you're going to put here. So when you put it, your negative is still there, your period is what you got here, your t, right? See it here, you put it here. So when you put it over your slope, the negative will cancel the negative, and you're going to get this as your relaxation time. When you come to the coefficient of damping, B is equal to 2m. So I checked, the best max of a bulb is 50 gram. We also have 100 gram, but 100 gram is heavier, so I chose to use 50 gram. So 2 times 50 divided by relaxation time you got here is where you're going to put here and get this. Then for your quality factor, your angular frequency times relaxation, you've gotten your angular frequency before here, and then your relaxation time that you got here, you get your quality vector. Then you begin to answer. You can browse about this on, you can browse using ChatGPT to help you. What does the slope represent? When its slope is negative, it means that the amplitude decreases with time due to the damping effect. The damping effect comes as a result of air resistance or friction. So that's why you can now browse about free oscillation, when a system vibrates without any external force, damped oscillation when it gradually reduces because of resistance, and all these things. So just browse every other thing. So these ones now are for experiment M2, simple harmonic motion. So just stay tuned for the next videos, and don't forget to subscribe and like this video.